The F-22 Raptor was supposed to become a museum piece, its legendary roar confined to documentaries, yet engineers refused to let America's air superiority icon die quietly. Instead, they embarked on a clandestine makeover, replacing miles of copper cabling with fiber optic nerves and slotting quantum-secure processors that crunch threats before the pilot even sees them. Then, they sprayed a metamaterial coating so exotic it bends radar and infrared alike, causing the jet to vanish into background static like a ghost hiding in plain sight. But the most radical upgrade is invisible code that rewrites itself every few weeks, teaching new dogfight tricks while the jet sleeps inside a climate-controlled cocoon, leaving rivals to guess what it learned tonight. This video pulls the curtain on 12 classified enhancements that turned a 5th-generation relic into the silent blueprint for 6th-generation air dominance. We'll start with stealth skin that breaks physics, glide into drag-free fuel tanks that let the Raptor sprint across oceans, and climax with a missile so smart it stalks enemies beyond visual range. Each reveal brings a bigger twist, because every new feature solves one problem, but secretly introduces a challenge the Pentagon has barely admitted exists. Stay locked in, because the final segment exposes a swarm tactic so disruptive that lawmakers hid the budget line in a footnote just to avoid public panic. By the end, you'll understand why Congress repeatedly blocks the Raptor's retirement despite its astronomical upkeep costs. You'll see why pilots call this comeback program Project Lazarus, and why China's radar operators now report phantom contacts they cannot chase. And you'll realize that if a retired jet can leapfrog a decade of research, the classified prototype meant to replace it may already be circling unseen overhead, ready to witness an aviation resurrection in real time. Let's rewind to the jet's birth to see how the legend started before it was reborn. When the Cold War's final embers faded, the Air Force needed a fighter that could shoot down threats before radar even rendered them as blips. And the Advanced Tactical Fighter Contest was born. Lockheed's YF-22 prototype combined stealth shaping, thrust vectoring nozzles, and supercruise to outfly and outthink every competitor during trials over the Mojave. Pilots described the jet as a telepathy machine because its fly-by-wire system predicted stick inputs milliseconds ahead, making the aircraft respond like an extension of muscle memory. With a radar cross-section smaller than a marble and the speed of a sprinting missile, the fighter earned its mythical first look, first shot, first kill mantra long before it received an official name. Congress funded full-rate production in 1997, convinced that owning the sky for the next half-century justified the $150 million price tag per airframe. Engineers stripped weight wherever possible, honeycomb composites in the wings, titanium lithium skin panels on the fuselage, to ensure the jet could out-accelerate anything flying above Mach 1. Even the cockpit became a technological marvel, using panoramic touchscreens to merge sensor feeds into a single God's eye view, a concept that would later inspire smartphone UI design. Every rivet, every line, every software module existed for one obsessive purpose: guarantee the pilot would see the enemy first and remain unseen in return. The aviation world held its breath when the first production F-22 roared off the runway in 2005, disappearing from radar towers minutes after takeoff. In red flag exercises, the jet racked a confirmed 144-0 kill ratio, forcing planners to fabricate new handicaps just to keep training relevant. Yet embedded in those wargame successes was an ironic seed of future trouble, dominance so overwhelming that politicians began asking why America needed more than 187 units. That budgetary doubt set the stage for a cancellation story so dramatic it threatened to erase the Raptor's legend before it reached adolescence. And that cliffhanger is exactly where we turn next. The 2008 financial crisis tightened Washington's purse strings, and lawmakers treated the Raptor's $80 billion program like low-hanging fruit ripe for a fiscal axe. Critics argued that no peer rival existed worth such extravagant stealth, claiming the jet's dogfight prowess was overkill for counterinsurgency wars in deserts and mountains. Pentagon briefings tried to defend the fleet, but graphs showing air-to-air missile launches against antiquated insurgent pickup trucks failed to move skeptical senators. The fatal blow landed in 2009, when Defense Secretary Robert Gates recommended ending production at 187 planes, declaring the era of dogfights effectively over. Assembly lines in Marietta, Georgia, fell silent. Thousands of skilled machinists boxed tools, assuming they would never carve another Raptor bulkhead again. Aviation journalists published obituaries calling the F-22 the finest warbird retired before fighting a real war, while adversary nations toasted the decision in closed-door briefings. Air superiority doctrine scrambled for a replacement, pivoting to cheaper multi-role platforms like the F-35, even though its program was still mired in development delays. Meanwhile, a quiet faction inside Air Combat Command refused to surrender, planting seeds for a resurrection project already nicknamed Phoenix. Classified memos revealed that embedded test data hinted the jet's airframe still had decades of growth room for new sensors, weapons, and power generation. Engineers argued killing the line simply paused progress, because secretly, they were already drafting upgrade blocks that could vault the platform beyond anything else in the sky. They understood that shuttering production didn't murder the Raptor, it hid it, waiting for geopolitical tension to justify its return. That return would begin under an innocuous acronym, NGAD, and it would transform the dead fighter into the world's most advanced test bed, as you'll see in the next chapter. Next-generation air dominance sounded like a blank check future fighter program, but its first step was startlingly simple. Retrofit the F-22 to carry the technologies no prototype could safely test alone. By using an existing stealth airframe, engineers avoided billions in wind tunnel hours, letting them focus on bleeding-edge subsystems rather than reinventing wings. The Raptor suddenly became both guinea pig and guardian, flying classified equipment under a blanket of existing operational security protocols. Each sortie doubled as a technology demonstration and combat patrol, gathering real-world data that simulation labs could never replicate. NGAD planners installed modular equipment bays wired to accept plug-and-play sensors, essentially turning the jet into an airborne USB port for experimental warfare tech. New mission computers ran on open architecture code, allowing subcontractors to upload capability packages the way smartphone users install apps. This agile approach replaced years of acquisition red tape with sprint cycles measured in weeks, giving adversaries zero time to adjust. Pilots would land with a gigabyte of new telemetry, debrief, and often take off the next day with upgraded algorithms that corrected every logged flaw. The plan's elegance was brutal. Let the old Raptor break new tech in, then port perfected subsystems to the still classified NGAD airframe. Once they survived real combat alerts, contractors quickly found that if an idea failed on the F-22, it probably wasn't worth scaling to the 6th-gen machine, trimming waste before it appeared in budget hearings. By 2022, internal reports showed the retrofitted Raptor fielding gear 3 development phases ahead of schedule, and adversary satellites could only capture grainy silhouettes. Yet hardware is nothing without a central nervous system capable of digesting terabytes of sensor fusion. A digital backbone will plug into next. At the core of the Raptor's rebirth lies a new mission computer cluster nicknamed Cerberus, a triple-headed processor able to run flight control, electronic warfare, and AI target identification simultaneously without crosstalk. Cerberus uses photonic links instead of copper, transmitting data at near light speed, while generating a fraction of the heat that once risked infrared detection. Its operating system compiles in modular blocks, meaning programmers can rewrite the electronic attack suite without touching flight control code, slashing update time from months to minutes. Machine learning models trained on millions of radar echoes now classify threats faster than a human can pronounce Fox 3, yet still leave the pilot in the decision loop. This digital elasticity empowers the jet to integrate new weapons from plug-in pods rather than hardwired pylons, treating munitions like downloadable content. Test pilots report that the cockpit's panoramic display now feels like wearing augmented reality glasses that annotate the sky with color-coded danger zones. Data links funnel sensor feeds to loyal wingman drones and back again, creating a distributed mesh that can route around jamming like water finding cracks. Engineers joke the Raptor is no longer an aircraft with software, but a software platform that just happens to fly at Mach 2. The pace of change is so rapid that ground crews sometimes swap out mission laptops on the ramp, giving the jet a fresh brain before refueling is complete. This agility terrified rival air forces because it meant no intelligence briefing could guarantee what version of the Raptor they might face tomorrow night. And the digital backbone was only step 1. Next came the outer shell, a metamaterial stealth skin that would make even Cerberus's speed seem slow compared to disappearing altogether. prepare to meet the paint that eats radar for breakfast. Traditional stealth relies on angled panels to deflect radar, but the Raptor's new metamaterial coating manipulates electromagnetic waves at the molecular level, redirecting them like a hall of mirrors. Embedded carbon nanotube lattices resonate with incoming frequencies, absorbing energy and re-emitting it as harmless heat that spreads across the wing in microseconds. Early ground tests showed a 70% reduction in radar cross-section, effectively shrinking the jet's signature from a marble to a B at ranges beyond 50 nautical miles. Infrared cameras fared no better, because the coating doubles as a thermal sink, smearing engine heat along the fuselage until it blends with ambient sky. The skin heals microablation damage by flowing polymer chains into surface scratches when warmed by the sun, eliminating maintenance crews' biggest stealth headache: tape-up repairs. Its conductivity also doubles as an antenna array, enabling edge-of-wing electronic warfare that no external pod could match without ruining stealth geometry. Pilots say the metamaterial turns the aircraft from a visible predator into a rumor, because radar operators receive ghost echoes that vanish before they can vector interceptors. The coating even tricks low-frequency search radars, which once threatened stealth jets, by phase-shifting returns into the background noise floor. Engineers warn, however, that the metamaterial is power-hungry, requiring constant energy to realign nanocells during high-G maneuvers. That demand forced them to upgrade the jet's electrical generators, which in turn unlocked enough spare capacity for something truly outrageous: an infrared search and track sensor that hunts other stealth fighters. With the skin now devouring radar reflection, the Raptor needed eyes that functioned without emissions, an ability we'll step into with the new IRST in the next segment. Because what good is invisibility if you can't spot the other invisible hunter first? The infrared search and track pod, mounted flush on the nose chimney, sees heat signatures so faint it once locked onto a suborbital rocket stage 120 miles away. Unlike radar, IRST emits nothing, letting the Raptor stalk targets with the patience of a sniper hiding under gilly leaves. Its cooled detectors slice the sky into thousands of thermal pixels, each processed by Cerberus to build real-time three-dimensional heat holograms. Enemy stealth jets designed to scatter radar now find themselves betrayed by engine plumes and skin friction glow they can't conceal. The system fuses with the jet's electronic support measures, comparing heat tracks to known jammer fingerprints, effectively turning enemy countermeasures into homing beacons. Cooperative data sharing beams these ghostly images to wingman drones, expanding the thermal picture across hundreds of cubic miles of airspace. Pilots report the eeriest sensation: chasing an adversary they can't see with their eyes or radar, guided only by a faint amber outline dancing on the HUD. And if that outline strays too far, the Raptor's newest range extender, the long drag tank, ensures the pursuit can continue across continents. But plumbing thousands of pounds of extra fuel into a super-cruising stealth jet without ruining aerodynamics required a pylon design so clever it deserved its own patent. The story of that drag-free tank reveals how engineers carved endurance out of thin metal, and it's coming up next. Stay tuned, because the Raptor is about to stretch its legs in ways no stealth fighter has done before. You'll soon see why even Pacific Island chains are suddenly within one tank of danger when the revitalized F-22 takes off. Traditional drop tanks ruin stealth by reflecting radar off their rounded ends, but the long drag tank hugs the Raptor's belly like a second skin, contour matched within millimeters. Its faceted composite shell continues the jet's stealth geometry, sharing radar-absorbent panel lines so precisely that software treats the assembly as a single surface. Internal bladders hold 1,800 gallons of JP8, yet maintain laminar airflow, adding less than 2% drag at cruise thanks to vortex-canceling Chinese. Clever explosive bolts blow the tank clean at Mach 1.6 without rattling stabilizers, ensuring the jet can shed the extra weight seconds before entering a knife fight. With the LD attached, the Raptor's unrefueled combat radius grows past 2,000 miles, a range once dreamed of only by bombers. Pacific war planners suddenly realized the fighter could leapfrog island defenses and still return home without tanker support. A logistical nightmare for any opponent relying on fixed runways. The tank's structural spine doubles as a broadband antenna, extending the jet's data link horizon so far that control stations in Guam can steer drones lurking off Shanghai. Engineers like to joke that the Raptor finally got its own prosthetic fuel pump, and it's one that doubles as a Wi-Fi router. Yet carrying that much extra fuel demanded improved thermal management, prompting tweaks to inlet ducts that paradoxically boosted supercruise efficiency. Those aerodynamic gains inspired a second upgrade cycle nicknamed Encore, aimed at restoring the jet's record-holding Mach 1.7 cruise sprint even with the heavier load. And when a fighter can cruise supersonic for hours, it needs teeth sharp enough to matter once it arrives. Enter the AIM-260 missile, the subject of our next reveal, because speed without reach is pointless, and reach without lethality is just expensive sightseeing. Engineers reshaped the Raptor's engine inlets with three-dimensional printed titanium lip extenders, smoothing shockwave patterns that had aged poorly with added payload drag. Wing root fairings received micro-vortex generators tuned in wind tunnels to delay boundary layer separation past Mach 1.5, preserving lift at thinner air. The Pratt & Whitney F-119 engines replaced aged turbine blades with ceramic matrix composites, increasing exhaust gas temperature tolerance by 50 degrees without sacrificing stealthy nozzle signatures. Combined, these tweaks restored the jet's ability to hold Mach 1.7 without afterburner for over 15 minutes. A sprint window pilots call running with the wolves. That sustained dash means the Raptor can reposition across a 200-mile combat radius faster than most adversaries can file an updated flight plan. Supersonic persistence also improves missile kinematics, because launching at high speed effectively gifts the weapon free range before its own motor even lights, which makes the arrival of the AIM-260 Joint Advanced Tactical Missile a perfect marriage of carrier and payload. But the missile doesn't just ride shotgun. It can think, pivot, and kill with a guidance suite that owes a surprising debt to smartphone autofocus algorithms. Before we dissect those features, remember that every second the Raptor spends cruising hot pushes thermal loads into the digital backbone we mentioned earlier. Yet Cerberus thrives under pressure, allocating extra processor cycles to predictive logistic models that calculate engine stress in real time. That living room thermostat-style oversight keeps the jet cool enough to fold space for the missile we're about to meet. So let's open the weapons bay and greet the JATM, the dagger forged to pierce the heart of modern air combat. The AIM-260 looks like a slightly longer AM RAM, but inside its graphite epoxy shell beats a dual-pulse motor that fires a second time in the final chase to swat maneuvering targets. An electronically scanned radome gazes off boresight angles wider than a car windshield, letting the missile sniff out jammers that think they've already slipped past its nose. Mid-course updates stream from the Raptor's data link, allowing course corrections based on real-time sensor fusion, rather than stale launch data. In wargames, the JATM scored a classified hit probability that forced range officers to shift threat drones 20 miles farther out, just to give them a fighting chance. What truly terrifies adversaries is the weapon's silent handshake with the IRST, enabling heat-seeking logic to kick in for a kill shot even after radar lock is lost. That dual-mode guidance makes traditional brake turns and chaff bursts about as effective as hoping rain puts out a blowtorch. Analysts estimate the missile outranges China's PL-15 by at least 20%, an edge that in aerial chess equates to checkmate 3 moves early. But future threats demand more than kinetic darts. They demand directed energy answers, and the Raptor's spare generator capacity just found a new hobby. Coming up, we'll strap a laser under a stealth jet's wing and watch power physics bend to ambition. Because when light itself becomes a weapon, distance stops mattering, and reaction time shrinks to the speed of thought. Stick around, the next revelation will make your sci-fi binge seem outdated. It's time to meet the directed energy pod that turns the Raptor into a flying magnifying glass focused on enemy drones. Nestled in a conformal pod, where older jets once carried external fuel, the high-energy tactical laser draws megawatts from upgraded generators designed for electromagnetic catapults on carriers. Fiber laser arrays combine into a single coherent beam, wide as a coin, yet hot enough to melt aluminum control surfaces in under 2 seconds. Because photons travel straight and unimpeded, the weapon functions at the speed of light, erasing swarms of cheap drones before their operators can spell launch. Stealth is preserved, since the pod's exit aperture is shrouded behind radar-transparent silica windows that maintain the Raptor's low observable contours. Beam director gimbals steer the laser silently, meaning no recoil or aerodynamic penalty compared with traditional guns. Integrated sensors measure atmospheric bloom and adjust focal length on the fly, writing invisible equations in the sky to keep power on target. In tests over white sands, a prototype pod burned through a target sleeve at 20,000 feet, leaving no debris for enemy propaganda photos. Yet every joule of energy the laser consumes comes at a cost, pushing thermal management systems toward the red and forcing clever power budgeting between weapon cycles. That's where loyal wingman drones become invaluable. They can carry extra power modules or act as decoys while the Raptor cools its concentrates. The partnership between manned fighter and robotic sidekicks is rewriting aerial tactics, and it's our next deep dive. Because you haven't seen cooperation until you've watched a stealth jet orchestrate a wolf pack of disposable hunters. Let's send in the machines and watch the sky turn into a chessboard of autonomous moves. Emerging from the belly of a C-130 like metal tadpoles, XQ-58 a Valkyrie's fan out and rendezvous with the Raptor minutes after it clears friendly airspace. Each drone carries its own sensors and weapons, but the Raptor's Cerberus brain acts as the pack alpha, delegating tasks via encrypted mesh commands. One drone might switch on a radar emitter to bait enemy air defenses, while another slips close with anti-radiation missiles, all while the mother jet stays dark. If a drone is shot down, the only cost is aluminum and code. No pilot letters, no political fallout. Autonomy algorithms let the drones continue missions even if comms jam, relying on mission trees preloaded before takeoff. Trials have shown the pack braking formation to encircle a hostile fighter, forcing it into vectors where the Raptor could pounce unseen. Meanwhile, extra fuel or batteries carried by cargo drones can top up the fighter mid-air through modular wing connectors, extending on-station time by hours. The psychological edge is immense. Enemy pilots now face not one predator, but an unpredictable swarm, guided by a ghost they can't find on radar. Loyal wingmen also serve as data mules, hauling terabytes of sensor intelligence back to base if satellites are jammed. That redundancy ensures every scrap of combat footage feeds machine learning updates before the next sortie. And all of this experimentation feeds straight into the design specs of the true 6th generation successor, whose silhouette hides behind black budgets today. Let's zoom out and see how the Raptor's metamorphosis sketches the blueprint for the next age of air dominance. Every upgrade you've seen, modular bays, AI backbone, metamaterial skin, high-energy weapons, drone integration, forms a plug-and-play checklist transferable to NGAD's still classified airframe. The Raptor's revamp is less about keeping an old fighter young, and more about de-risking tomorrow's weapon system without exposing it to satellite cameras. This living experiment lets designers verify stealth coatings in thunderstorms, missile data links under real jamming, and laser pods during dust storms, gathering data no wind tunnel can simulate. Each lesson flows into digital twin models that refine NGAD's lines with every touchdown of the Raptor today. Pentagon planners admit privately that the fastest way to build the future is to fly it in pieces, and the Raptor is the world's most capable Lego set. Rumors already hint that NGAD's cockpit will be optionally manned, borrowing Cerberus's ghost pilot logic proven over conflict zones by its predecessor. Supply chains have shifted toward additive manufacturing because stealth field repairs tested on the Raptor's metamaterial showed 40% faster turnaround than traditional patch kits. Even engine architecture for adaptive cycle turbofans drew thermal lessons from stuffing power-hungry lasers into the Raptor's belly. So when the Air Force finally unveils NGAD, many will gasp at its alien shape, unaware they have already seen its heart beating inside a legacy Raptor for years. And if the Raptor's resurrection taught the world anything, it's that you should fear the jet you think retired, because ghosts make the best ambush predators. Before we close, one final mission brief awaits, a rapid-fire recap that ties every upgrade into the strategic stakes shaping tomorrow's skies. Stay for the summary, then jump to our next video on the classified rollout schedule, because this saga is only at halftime. The F-22's second life began with a cancelled production line and ended with a stealth juggernaut wielding metamaterial skin, infrared hunter vision, drag-free fuel limbs, and a missile that stalks across horizons. Add a laser that slices drones, a digital brain that rewires itself, and a wolf pack of loyal wingmen, and you have a machine that writes its own legends while flying them. Every bolt and byte now feeds NGAD, proving retirement can be the perfect cover story for reinvention. And somewhere above, the first 6th-generation prototype likely banks silently, carrying hand-me-downs perfected by this resurrected king. Meanwhile, rival commanders must plan around an invisible jet whose playbook updates in real time, knowing every new patch may contain the trick that ends their careers. War has always loved deception, but never before has a fighter hidden its deadliest secrets in plain sight, wearing yesterday's uniform to fight tomorrow's battles. Congress may one day finally sign the Raptor's retirement order, yet every signature will echo with doubt, because history just proved that death certificates can be forged. The sky, it seems, keeps its royalty on retainer indefinitely. If this is what a supposedly obsolete airframe can do, imagine the classified monster slated to replace it. And remember that budget hearings often lag reality by years. The next chapter of air dominance is already cruising above the radar horizon. You just witnessed its dress rehearsal. If you want to follow the reveal countdown for NG's public debut, tap into our follow-up linked on screen now, before that video gets quietly delisted for security concerns. Until then, keep your eyes on contrails that appear and vanish unexplained, because legends never retire, they simply change their call signs.